The cosmic microwave background, in a sentence, is the presence of persistent electromagnetic radiation in the form of microwaves that permeate the entire universe. The energy of these waves is essentially unnoticeable to the human senses unaided. However, sensors grew more precise throughout the 20th century, and scientists were able to not only detect the presence of a background radiation, but also use the energy of these waves to determine the temperature of the universe.
Space, littered with stars, planets, galaxies, and other heavenly bodies, the vast majority of space is exactly that, space. There exists a variety of phenomena readily observable and interesting to normal human perception, such as supernovae, black holes, and neutron stars. Space, however, is full of surprises. The interstellar phenomena that are loud and exciting attract the most attention. However, space's defining characteristic is the sheer scale of its emptiness. In these areas of empty space, it would seem that there is nothing. No mass, no temperature, no light, only the void. These regions of space are filled with one persistent, undying phenomenon, the cosmic microwave background. In this video, we will explain the meaning of the cosmic microwave background, explore its discovery, and attempt to understand what it means for the future of the universe.
The stray microwave energy is the echo of the Big Bang, the rapid inflation of the entire universe some 13.7 billion years ago. These photons in the present-day cosmic microwave background have a temperature of about 2.7 Kelvin, meaning that the CMB acts as a sort of universal thermometer. These present-day temperatures are a far cry from the 116 billion Kelvin just moments after the Big Bang started.
Static surrounds us, annoys us, but in the right context can reveal many hidden features about the world around us. Every one of us has turned on a TV or radio only to find an indiscernible signal, but it is this same static that resulted in the discovery of one of the most fundamental components of the universe. The cosmic microwave background was one of the most important breakthroughs in science of the last century. Shockingly enough, its discovery was completely by accident. It's important to note that its existence, however, was not a complete surprise. It was first speculated to exist in 1948 by theoretical physicists Ralph Alpher and Robert Herman, though it was not initially referred to as the cosmic microwave background. Its temperature was measured by them to be about 5 Kelvin, though they later revised this estimate to around 28 Kelvin after a misestimate of the Hubble constant. Following these initial estimates, many other scientists put forward their own calculations with varying degrees of uniformity.
It wasn't until 1964 when two American radio astronomers by the names of Arno Penzias and Robert Wilson were using a horn antenna for experiments concerning radio astronomy and satellite communications that the cosmic microwave background was first accurately recorded. At first, the astronomers thought that the persistent noise that they heard in the background of the horn was debris. They even cleaned the horn itself of bird nesting so that they could get rid of the sound. It did not go away whatsoever, and thus they realized that what they were hearing was actual proof of the CMB. Following calculations proved the temperature of the cosmic microwave background to be about 2 Kelvin.
These temperature measurements were calculated by transforming the relationship between a photon's wavelength and its energy. A photon's energy is equal to the speed of light multiplied by a number known as Planck's constant, and then divided by the wavelength of the photon. Photons themselves do not have temperatures, as only massive particles are capable of possessing temperatures, but they act as carriers of energy. These photons interact with regular matter and transfer a small amount of energy to them, a process which increases the temperature of the object. The temperature calculated from the cosmic microwave background is the amount of temperature increase of an object due to the burst of radiation released during the Big Bang. This fundamental universal temperature is instrumental in describing cosmological history. However, the cosmic microwave background is not homogeneous, as demonstrated in the blotchy heat maps of the background.
The cosmic microwave background acts as a sort of historical record for the past, present, and future. It is important to understand that while its presence is undeniable, its impact is waning. As the universe expands, these microwaves become gradually more dispersed, And while they will never entirely dissipate, they will disappear further into obscurity.